welcome to day 13. I'm super late on Advent of Code day 13. I had lots of grading and shit to do today. But I'm done now, and I'm ready to knock this out. Let's see what we got. Is this music too loud? Music is kind of loud, huh? Let's chill that out a little bit. Maybe it's still too loud. We'll do it like right there. How loud am I? Maybe kind of loud too. Alright, we'll do it like right there. Okay. I'm probably going to turn it off anyway. I can't think and listen to music. Next up, the lobby of a... Please, I just hope I don't have to do like reflections here. The lobby of a resort on a tropical island, the historians take a moment to admire the hexagonal floor tiles before spreading out. Fortunately, it looks like the resort has a new arcade. Maybe you can win some prizes from the claw machines. Yeah, right. The claw machines here are a little unusual. Instead of a joystick or directional buttons to control the claw, these machines have two buttons labeled A and B. Worse, you can't just put a token in and play. It costs 3 tokens to push the A button and 1 token to push the B button. Interesting. I think I smell some combinatorics coming. With a little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right. Each machine's buttons are configured. I'm gonna have to turn this music off already. The little experimentation, you figure out that each machine's buttons are configured to move the claw a specific amount to the right along the x-axis and a specific amount forward along the y-axis each time that a button is pressed. Each machine contains 1 prize. To win the prize, the claw must be positioned exactly above the prize on both the x and y axes. You wonder what is the smallest number of tokens you would have to spend to win as many prizes as possible. Okay. You assemble a list of every machine's button behavior and prizes and prize location. Your puzzle input looks like this. What is the smallest number of tokens you'd have to spend to win as many prizes as possible? So we've got our configurations here for each machine. This list describes the button configuration and prize location of 4 different claw machines. For now, consider just the first claw machine in the list. Pushing the machine's A button would move the claw 94 units to the right and 34 units up, we're gonna say. Pushing the B button 22 units, 67 units, and the prize is located here. This means that from the initial claw's position, it would need to move exactly 800 or 8,400 units along the x-axis and exactly 5,400 units along the y-axis. Okay. The cheapest way to win the prize is by pushing the A button 80 times and the B button 40 times. This would line up the claw along the x-axis because this, and along the y-axis because that. Doing this would cost 80 times 3 tokens for the A presses, 40 times 1 for the B presses. Yeah. Total of 280 tokens. For the second and fourth claw machines, there is no combination of A and B presses that will ever win a prize. For the third claw machine, the cheapest way to win the prize is by pushing the A button 38 times. Yeah. You estimate that each button would need to be pressed no more than 100 times to win a prize. So the most prizes you could possibly win is 2. The minimum number of tokens that you would have to spend to win all 2 prizes is 480. You estimate that each button would need to be pressed no more than 100 times to win a prize. Okay. How else would somebody be expected to play? Right. Figure out how to win as many prizes as possible. What is the fewest tokens you would need to spend? So definitely gonna do some combinatorics here, I guess. I'm gonna use combinations to solve it. And I think I'm gonna do it just like recursively. Let's see. Let's get all my boilerplate. It's not the test. We love Java boilerplate. Get my test in there. I still gotta clean up the past few days. We're finishing them, but we're just getting behind on like keeping them pretty. Implements. Test day. But now I don't have any more school, so I should be able to catch up. And in here we're gonna have our sample data. Which is gonna be this. And we're gonna have a day 13. That's gonna get reinitialized every test. And the expected answer for that is 480. The actual is going to be my day 13 part 1. And we're going to assert that those are equal. Okay. And let's go ahead and do our sample file in here. 13 sample. Let's go ahead and get our real input too. Okay. All right. Next year I'm doing this in a different language. I'm trying to learn Go right now. Okay, great. Wait. Oh, we didn't put an equal sign in there. That's not why we want to fail that right now. Let's actually define it. It's fine if it's defined right now. And part 1 string sample or data And okay. TDD, guys. What? It's not. Oh, gotta put the sample in there. I just want to fail for the right reason, okay? Okay. Oh, and this one, I can just like... We're not there yet. Okay, okay. Now let's actually do it. So, I'm gonna have some machines. I might do a little OOP here. Make maybe a class for the machines. And a machine has 2 buttons. Yeah, let's do it. We don't need to, but we will. Machine. It's gonna have 2 behaviors. That's gonna be press A. These are gonna be voids. And press B. And we're gonna have a claw in here, right? Am I gonna make another class inside here? Let's see how ridiculous this looks first. Y. Claw. So they start at 0, right? I'm assuming. I don't really need to do all this, but... So we're gonna have a claw. And... claw. Machine. I'm just gonna say claw equals new claw. And yeah, that's really all we need. And when we press A, oh, we actually do need to know the X or A config. One, two, three, four. Oh, and the prize is... What am I doing? I don't know. Prize. We're getting crazy. And this will take a couple args. And the machine, it's gonna take a Y. And it's gonna take the prize X and the prize Y. And we're gonna say the claw is gonna be a new claw. We're gonna have a prize as well. Yeah, this is dumb, but whatever. Prize equals new prize. And this is gonna take, yeah, the PX and the PY. What is AX, AY? Oh yeah, those are the configs, so maybe I'll set that in the claw. Yeah, I'll do that. That's the x and the y. And we also want to know the step, right? X step and the y step. X step, y step. Yeah, the x and y are going to start at 0, and then this dot x step equals x step. This dot y step equals y step. Step claw. And when we press A, x plus equals x step. And when we press B, oh, that's right. Y plus equals oh yeah, x step A, y step A. We're also gonna have x step B, y step B. Why did I choose to do this? I don't know. I'm just kind of running from solving the actual problem right now. Okay. And y plus equals y step A. And then when we press B, same thing. X plus equals x step B. Y plus equals y step B. Yeah, it's ridiculous. No need to do all this, but I want to have little objects, okay? So I have a machine. It has a claw and a prize. And for a claw, we need to pass the configurations, which is going to be that AX, AY, BX, BY. And the prize, we're gonna put the prize where it needs to be. And every time we move, we'll just say like machine dot claw dot press A. Machine dot claw dot can grab prize. Oh, that'll be a machine behavior. Can grab prize. And we're just going to return claw dot x equals prize dot x, and claw dot y equals prize dot y. Easy peasy. Right? Yeah. Okay. Now we can actually solve the problem. So I want a machine. We're gonna have to parse this data, so I'm gonna have a list of machines. Oh yeah, we don't want to do that then. We're gonna have a list of machines. Yeah, list of machines equals load machines data. Load machines string data. First we want to split that stuff by, let me look at it real quick. Split it by new lines to get each little chunk, or split it by empty lines, sorry. So split it by a double new line. Let's trim it first. So trim it, split it by double new line. That'll give you each of these guys. Should be able to do this with streams. Return data dot trim. We're gonna do this arrays dot stream data dot trim dot split by double new line. That'll give us each config, and then dot map each one of those configs to a machine. I may need a body for that. So each config needs to be split. Let's see. I could just split it by new lines first. I'll just call it spec. Specs equals config dot split by new line. And the first part is the button A configuration. So, which is AX and AY, and then BXBY, and then PXPY. Okay. AX, B or AY. BX, BY, PX, PY. And let's see if I split this by colon space, button config. Maybe make a method for that. That's like a nice clean way to get this number right here. I mean, I could use substring. It'll be like the first index of the first index of a plus to a comma. Yeah, we'll just use substring, and then last index of a plus to the end. Same here with the second part, and for the prize it'll be index of equal sign plus to the comma, and then last index of equal sign to the end. Yeah. Percent specs 0 dot substring. We're gonna go. Well, let's do this. String A spec equals specs 0. B spec equals specs 1. P spec equals specs 2. Let me check on my French fries. Looking good. Whoa. Spec A dot index of wait. Substring. So we're gonna say A spec dot index of the plus sign +1 to the index of comma. So that's gonna be the A spec, or that's gonna be the AX, and all these are gonna be pretty similar, something similar. Ugly. Yeah, it's probably a more elegant way to do this. And then AY is gonna be the last index of plus sign, and I don't need a second arg. This is gonna be B spec, B spec, B spec, B spec. Well, this will be last index of the plus, and no second arg. And then this will be index of the equal sign +1 to an index of a comma. And index of last index of the equal sign yeah, no second arg. Okay, so that gives us our things here, and then we can just return a new machine with all of those configs passed in as args to the constructor, and then just collect this to a list. Boom. That's our machine parsing. So we got our machines now. And now we want to actually do like the combination stuff. Now I want to do the combination stuff. So I set the max number of button presses is going to be 100 for one button. How am I going to do this? I want to do it like with combinatorics. Shoot, I think having the objects was not a good idea. Let me see something here. Dang it. What am I interested in knowing? Just the number. Yeah, the number of the number of tokens. So num tokens what am I going to take here? Let me think about what I... Yeah, let me think. We're going to have... Yeah, I might not even use those objects that I just made. We're going to have the prize position. And we're going to have... we're going to have the claw position. Yeah, honestly. Yeah, because I want to do this recursively, and I'm going to be... I can't, like... I could keep making new instances of these as I go through, but that's dumb. So I'm just going to use numbers. So I'm going to have the prize position, the claw position, and then I need to know, like, the steps. So AX, AY, Y, BX, BY, and we said if there's button presses, num presses, we'll say num a presses, I don't know about this. If num a presses is greater than 100, wait, was it at most? No, more than, yeah. Or num b presses is greater than 100. Then what do we return here? So if the number A presses is less than 100, the num B presses is less than or equal to 100. Because we're about to press a button. We're going to return. So what can we do here? We can... What are our, like, options? If we're going to think about this combinatorically, we can push A or we can push B. Yeah, we can push A or we can push B. And we want to know and this should return the number of tokens. Oh, I do need a base case. Ugh, oh my gosh. Alright, now actually I'm going to revert this back to be if it's greater than 100. Actually, I need to say if this will actually be, well, that'll be a base case too. I'm going to change that back again. Num tokens. If we've reached the prize, so if PX equals CX and PY equals CY, then we've reached the prize. Return num tokens. And then if we're still under the number of presses here, and I want to return a min. So let me do this. Return math.min. Look at all those freaking args, dude. So that part's not gonna change. Yeah, num tokens. Goodness gracious. That's a better way to do this. I don't know what I'm doing. by num A presses. Num B presses. And num tokens. I'll say tokens actually. We lost a fry. It went to the bottom of the oven. It's just gonna stay there until it becomes carbon. What's the problem here? Oh. Oh, whoa. Yeah. Alright, so we can either press A or we can press B. So pressing A is going to look like... That's pressing A. And num A presses goes up. And the number of tokens on an A press was 3. Yeah, 3 tokens to press the A button. And then the other option is to press B. BX. BY. Num A presses stays the same. Num B presses goes up by 1. And the number of tokens goes up by 1. And yeah, that should work. Might be like super slow. I should definitely do some dynamic programming here. So yeah, we didn't even end up using all these freaking things, dude. Tragic. That's what I get for trying to do like bottom up design, or top down, whatever. Okay, so now all of this is trash. Let's just return an integer array, or we'll do a list of integer array, a list of configs. We're gonna map each config, yeah, just like that. And instead of that, you can just return a new integer array. Like that. Yep. So those are our configs, and let's see. Tokens, and then for each config What? Oh. For each one of those guys, we're just gonna say tokens. Oh. Oh, okay, yeah. It'll return int.max value if it's not found. Num tokens. Total, I'll say total tokens. Cost equals num tokens. Oh my gosh, look at it. All right, how many freaking things are in there? 1, 2, 3, 4, 5, 6. Is that 1, 2, 3, 4, 5, 6, 7, 8. These will all start with 0. Yeah, 1, 2, 3, 4, 5, 6. Wait, what the heck? Oh, you'll have a claw. These will start with 0 too. So you're gonna have I'll call this C. So we're gonna have what's getting in there first. Let's flip this just so it's a little better. So the prize, the A step, and the B step. Prize, claw, A step, B step. Prize, the claw position, and then the A step, and then the B step. And then the number of presses, number of B presses, and then the number of tokens. And then if that's not integer.max value, if cost is less than integer.max value, crap. Total tokens plus equals cost. Then at the end you just return total tokens. Have I done it? Have I done it? I don't know. No. Oh. Oh. Seems right. No. Oh, number format exception. Alright, I should have tested my parsing logic earlier. On line 40. Oh, wait. Well, let's see where it's happening in 13. $57. What? Hold on. No. What? Are you sure it's on 57? Oh, yeah, wait. I guess it's something in here. Let's see. Okay, so the the X config is going to come. Let's see. First of all, I'm splitting by new line. Well, let's actually let's print that out real quick. Let's print those out. Yeah, specs. Print those out real quick. Yeah. Cool. Oh, there it is. Somehow I'm getting this. X plus 9. Is plus... Oh, it is. I'm gonna have to escape that. I always forget about these. These are regular expressions, so I have to escape that plus character. Oh, for input string. Okay, now I got the whole string. Saying index of that plus 1 to the comma. What in the world, boy? Do I need to escape that? What was it earlier when I did this? I think I do need to escape those. Yeah, plus is totally a regular expression thing. Oh, now I'm getting the whole thing again. What's the same thing I was getting earlier? Oh my goodness. Yeah, you do need to escape these. And I need to... That's 0. This is 1. This is 2. Whoops. Why? Am I getting these? Let's see. Let's just see what am I getting that? What am I getting? No, I'm not getting. What? So I'm saying a spec. Let's print out a spec here. And I'm saying index of the plus. I'm saying substring. Sweet. I'm trying to get jobs. I've just been texting people on LinkedIn. Got a thing at noon tomorrow now. Okay, what's going on here? What the heck is going on? Button A literally looks like that. Index of takes oh, it is a substring. Then it shouldn't be that. It's not a regular expression. Okay. Ugh, I'm so silly. Okay. See what this guy said. Awesome. We exchanged emails. LinkedIn's like Tinder for like jobs. Not really. Okay, so I'm actually parsing the stuff now. And we're saying 69. That's obviously not correct. Are we saying 69? Oh, we're still running. Okay. Infinite loop land. Wait, or is it just mad slow? Because I should get, it might just be being super slow. Raise.toString config. So we're on that first guy. Yeah, we gotta. How can I memorize this? So I'm actually exploring all the combinations. I don't think I actually want to do that. I'm exploring every single combination. Oh, we can totally memorize that though. Yeah, you could. So you'd be, let's see. What would you be mapping? You'd be mapping the claw position. What would you be mapping? Claw position. Like, you don't need all these args. Claw position. The number of presses. No, I don't think that matters either. Just claw position. Yeah. Claw position. We're going to map a pair of integers to an integer. So the claw position to the number of tokens. Come on, sucker. And then in here, I could just like make a new one every time. And then down here, so I have those two options. I should map them. Map.put if absent. New pair. Integer. Wait, I don't need to do that. New pair. CX, CY, and option 1, do the same with option 2. Oh, wait. Oh, it's not just a pair. You want to map the, Oh, wait. What the? Wait a minute. Oh, yeah, what am I doing? Hold on, map contains key. There should be like else. Yeah, get these options. Get those options in there. Don't need this part. Oh. Actually, just get that result with math.min again. Oh. Put those suckers in there. Whoops. Boop. And then map.put if absent, new pair. Hi. CX, CY, result. Return that result. I think that's what I want to do. There we go, 480. That's the white answer. So let's do it with the real one. Took me kind of a long time. I kind of wasted a lot of time making those stupid objects in the beginning. Yay! Alright, part 2. Please don't be crazy. As you go to win the first prize, you discover that the claw is nowhere near what expected to be. The claw is nowhere near what expected. Due to unit conversion error in your measurements, the position of every prize is actually this much higher than... Okay. To the X and Y position of every prize after... Okay, so just literally add that. That's not even crazy. Okay. We need to use a long now though. This part shouldn't need to be a long, but the positions need to be a long. So yeah, the positions need to be a long. Just for the prize, right? Yeah. The actual steps can stay integers. Yeah. And this is gonna have to be longs now. Okay. And then the positions, this'll need to be a long. Crap. Alright, we can change it all to longs just for like simplicity. No big deal. Alright. What? Where? Ah. Okay. What? Okay. Who's mad? Who's mad? This is gonna be some longs now. No. Oh crap. Come on, dude. And I'm gonna have to long.parse long. Yeah. Long dot parse long. What? What's your problem? What actually is your problem? Okay. There it is. Alright. Oh, and now I need to add this much to each of the prize positions. That wasn't too crazy. And what should the answer be now? with 100 presses. Wait. Now is only possible when the second and fourth claw machines. Unfortunately, it will take. So what is the? What should the answer be then? 0? What? Okay, that doesn't seem right. Now it is only possible to win a prize on the second and fourth claw machines. Right. Now it is only possible to win a prize with the second and fourth claw machines. Oh, now we actually... Oh, goodness.